Everybody knows that the integral of log of x divided by 1 minus x from 0 to 1 is negative zeta of 2. Now, a slightly smaller subset of everybody knows that the integral from 0 to 1 of log squared of x over 1 minus x is equal to 2 times Apéry's constant, or zeta of 3. And perhaps it's not everybody and their mother who knows this, but a lot of people know that the integral from 0 to 1 of log cubed of x over 1 minus x is equal to negative 6 times zeta of 4. And guess what? We're going to solve the general form of this integral, the integral from 0 to 1 of the log of x to the power alpha divided by 1 minus x. So let's see if we can't solve this integral. The first step is going to, of course, be to expand this 1 over 1 minus x with its power series, because we're within the interval negative 1 to 1. So we're going to do all that and then switch the sum and the integration operator to get here. Now, like magic, I'm going to take this integral and turn it into a gamma function. First, I'm going to make the substitution that x is equal to e to the u. One reason for this is the log of x to the power alpha is going to turn into u to the alpha, and then x to the n is going to turn into e to the u times n. This will also change the bounds from being from 0 to 1 to negative infinity to 0. And so once we work out the substitution, we'll end up here. We have the sum over non-negative integers of the integrals from negative infinity to 0 of e to the u times n plus 1 times u to the alpha du. Now I'm going to make one more substitution where I let u times n plus 1 equal to negative t. I'm sort of using this substitution to do two steps at once. One is to flip the bounds of this integral such that we're going from 0 to infinity instead of negative infinity to 0, and the other is to get rid of this n plus 1 in the exponent of the e here. And once we work out this secondary substitution, what we'll be left with is the sum over non-negative integers of the integrals from 0 to infinity of negative t over n plus 1 all to the power alpha times e to the negative t dt divided by n plus 1. Now what I'm going to do is selectively pull out some terms and make the magic happen. I'll start with this negative 1 to the power alpha, and in fact I'm going to rewrite negative 1 as e to the I pi, so I can write e to the I pi alpha. I'm also going to pull out these 1 over n plus 1 terms, which will amount to 1 over n to the alpha plus 1. And now that we've done all this work, we can finally part together our beautiful result. Least interestingly, we have this e to the I pi alpha part, which is just this little whirly doodad that circles us through the complex plane depending on what alpha is. This sum part needs no introduction, as it's the zeta function evaluated at alpha plus 1. And of course, this integral is the wonderful gamma function evaluated at alpha plus 1. And so this is what our beautiful integration result looks like. I don't know what else you could ask for in an integration. We have this wonderful exponential, the zeta function, and the gamma function all nestled into one. Anyhow, that's all for now. Thanks so much for watching, and I hope you have a nice day.